A while back, I was teaching a course for IT professionals. The students were super smart, technically skilled, eager to solve the problems, and deeply passionate about technology and digital technology in particular. But when we talked about the professionalism, something didn't really click. Um, Majority of them saw it as like a paperwork, some policies, or just a bunch of soft skills. They had nothing to do with them to writing a great code or building a great system, an efficient system. And I realized this wasn't only a classroom issue. This is probably a mindset issue across the IT industry in general and IT education in particular. So I started thinking, what if we approached professionalism not as a set of rules, codes of conducts, or simply some ethical frameworks of the practice, but as a way of thinking about technology itself. And that's where socio-technical thinking comes in. It has a deep root to my educational background and research activities. It's simply not about making IT ethical or something socially good or relevant. It's about seeing technology for what it really is, a system, a digital system in particular, that shapes and is being shaped by the people, organization, and power structures. So in this talk, I'm not just going to give you history or theory. I will try to talk about why IT professionalism fail when they ignore the bigger picture, which we can adopt from the socio-technical thinking, and how adopting a socio-technical mindset, a lens, can make IT experts not just a better coder or system builder, but a better strategist, a better leader, and a more valuable professional, both for themselves and for the community as well. So I'm going to cover some of the classic examples of the IT failures and some more recent ones to show you what are the similarities and differences, what remains the common source of the problem, how power and politics shape technology, and most importantly, how you can use this thinking for a future-proof career. By the end, I hope you will never look at the IT in the same way. So let's get started. Okay, in part one, I'm going to put on stage for you. Let's start with a simple question. Why do IT project fails? Okay, most people think it's because of the poor coding. Okay, there is a bug, system bugs, for example, or sometimes we think of the infrastructural issues, like the data center we've used, or communication technologies underlying the interaction between the digital systems. But that's only part of the story, probably a big part, but it's not the full story. Many IT failures have nothing to do with the technology itself. They fail because they don't fit into the social and organizational environment where they are implemented, adopted, and used. Yeah, that was the reality is the fit issue. A classic example of the major IT failure is London Ambulance Service computer-aided dispatch system, and what we can learn from it for the benefit of socio-technical system. Back in early 1980s, the London Ambulance Service wanted to upgrade its dispatch system, just like the police and then other departments were doing at the same time. The goal, automate ambulance dispatching, so that most calls would be handled by a computer. The computer at that age, with the human intervention only when absolutely necessary. Does it sound similar? Yes, it's very similar to the many AI automation these days. Anyway, but things didn't go as planned. After an earlier failed prompt, after an earlier failed attempt, they tried again in the 1990s, this time aiming for an even more advanced system. So they failed, and then they say, okay, so we need a better system here. So system only considering the technical system as a barrier for the low adoption or problematic adoptions. It was ambitious, but the complexity of the London geography, social dynamics, internal culture, which we are going to talk about it later, wasn't fully considered. When the system launched in October 1992, it failed dramatically. So there are lots of news headings and case studies around this one that you can search online and get yourself more contextualized. So dispatches were delayed, ambulances get lost, and the media had a failed, and media reported this failure excessively. What lesson we can learn? Big system needs careful planning, user input, deep understanding of the real-world environment, which in this case was the geography of the London as well. So fast forward to 2020. So it captured the gap, and after many multiple redesigns, a new system fully went live, but this time successful. Okay, using this case, I would like to clear up a common myth, and that is IT professionals often think that if they build a great system, people will use it. That's something we need to kill. We need to clean up at the beginning. It's only a myth. Technology adoption is never automatic. It doesn't happen by itself. If a system doesn't fit into the way people work and live and behave, it will fail no matter how well it's designed. If we need to change the behavior, we need to take consideration that aspect as well. In reality, technology fails when it doesn't fit with the people, processes, and institutions. Even the most advanced systems can crash and burn if it disrupts how people really work and clashes with some of very deep cultural aspect or embedded practices of the organization. So why IT project fails? So there might be a mismatch between workflows, the new system technically impressive, but doesn't align with how employees actually work and do their jobs, and lack of user involvement. Developers often assume the user will just figure things out, but with the input from the people, not getting the voice. So it is going to be problematic. Ignoring the workplace culture. So every organization has its own way of thinking and its way of doing things, which is the mind of the organization and the body of the organization. If a new system disrupts long-standing habits, traditions, informal way of doing things, employees may push back instead of embracing the change, and failure to account for the power dynamics. Sometimes there is no issue of the feet, there is no issue of the training, there is no issue of the skills. So the only concern is the power dynamic. So IT doesn't change processes simply, and people know that one. It can shift control, and that's a big deal for many people. If a system reduces one person, one manager decision-making power, or shift team dynamics, there might be some resistance or workaround somehow. Again, a great example of this power dynamics case is the Price Waterhouse attempt to introduce Lotus Notes Lotus Notes is kind of an early group collaboration tool. So imagine like the grandfather of the teams today. Okay, we might call it in this way. Executive thoughts at the time it would be a game changer, but they forgot one thing. Their consultants were under pressure to bill every working hours, and using Lotus Notes didn't contribute to billable work. So employees had no incentive to adopt it. Okay, it couldn't make the it could make the part of the work invisible. Okay, which is not billable. The system was technically fine, but socially more from power dynamics perspective misaligned, and then it failed. What this tells us about the IT failures is sometimes it's not a software issue, it's a social issue, in this case, a very political issue. Okay, let's move on to the next part, which I'm going to talk about the history, the historical evolution of this kind of thinking. For most of the history, people don't think about technology in isolation. Okay, that's very good. They thought about how it fit into the work and society. So if you want to look at probably not very close technology thinker, you might start with Marx Rebel, who introduced the idea of bureaucracy, which is a structure rule-based way of organizing the work. It made the organization efficient but also rigid. Okay, and then followed by that we had an idea of the people who emphasized what really matters is to look at the decision making and collaboration within the people. So and it has been shifting how to organize the work between these two extremes, for example. But what happened with the industrial revolution? We saw machines being introduced into the workplace. Okay, so that was the massive adoption of the machines at the factories, and faced a new way of managing work. And this had actually consequences far beyond simply using a tool by the people. Okay, and what was the movement? We need some sort of reflection, and instead it became something that restructured jobs, the labor market, business operation, so the processes. These early theories laid a foundation for the socio-technical system thinking. The idea that you can separate technology from the society and the way the people work. One of the first breakthrough in socio-technical system came from studies in British coal mines in 60s. So researchers found something relatively surprising. So introducing new technology didn't always make workers more productive. So because the idea was we give them the tool they need, so they need to be more productive. In some cases, productivity dropped because the technology disrupted team dynamics and existing work patterns. This has led to the creation of the socio-technical system as a theory, which for short they call it STS. STS states that organizations are not just technical, they are social systems too. Okay, we have another STS. Don't confuse these two. So the STS we are talking about right now is the socio-technical systems. If we don't align new technology with how people actually work, it will fail. Okay, and that was an extensive study has been done on people with the new technology, the productivity hadn't improved. This principle still applies today. So whether it's a software development, AI, or automation. Another large-scale example is the internet itself. So most of us think that internet as like a commercial product. So, but its origins were deeply socio-technical issue in nature. The U.S. Defense Department funded ARPANET to create a secure, decentralized communication system. Universities play a major role in developing the technical foundation, and institutions, 200 sites, I believe, like the research labs, needed a way to share the knowledge efficiently. We had a need, we had a technical, we have the money, put them together. All in short, the internet didn't succeed just because it was well engineered. It succeeded because it involved the key actors and met the diverse socio-political needs of the time. So it's an oversimplification to say, oh, okay, tech drives technology. The tech becomes part of the change itself, alongside with the other social forces, including economic forces as well. Socio-technical thinking applies to the organizational setting as well. So we have talked about more national one in the previous example. Historically, in 1970s up to 1990s, businesses invested heavily in IT systems like the MIS and decision support systems. They were designed to help organizations manage data and make better decisions. Okay, the ways of managing data in general. But many of these systems failed due to non-technical issues. Users were not involved in system design. Actual processes were super simplified, or less visible things such as symbolic or cultural values. One good example, still classic, is the Golden Triangle case, where a corporation introduced an IT system to centralize financial data. So, okay, it's a very well-defined objective for many components. It makes perfect sense from corporate perspectives. However, division managers resisted it, seeing it as a kind of threat to their decision-making power. And then instead of improving efficiency, the system created tensions and conflicts and ultimately failed. This is exactly how things unfolded in three kind of small stories. First, division managers saw it as a threat. Okay, they're worried about centralizing financial data meant losing control over their own decision making, instead of seeing the system as a helpful tool. Then resistance took many different forms. Okay, so managers outright refused to cooperate. Others attacked the system design, claiming it was technically wrong or unworkable. So they were not about the software, but the underlying issue was authority and control. And finally, the conflict dragged for many years. Meetings, debates, internal battles consumed countless hours. Some even tried to sabotage the system. The tension got so bad that the head of the accounting for one division was removed, which ironically helped calm down the situation. And in the end, it's not just an IT issue. It was a political struggle. So this example proves that IT is never just about the technology. It's about power, politics, and how people perceive change, authority, control. And I have shared a very old example to show you with this one. Even with the older tech generation, the social issues remain pretty much same. In fact, you might be thinking, okay, that was the past. Surely we've learned from those failures, right? Well, okay, not quite yet. Okay, many modern IT failures are extremely similar to those of the past. Again, because of non-technical issues. And today's challenges like the bias in AI, for example, automation replacing job, data privacy concerns are all deeply socio-technical problems in nature. They won't have simple technical fixes. The lesson here is clear. We need socio-technical system no more than ever. So these examples I've given you are very tricky ones. The bias, for example. So jobs are being removed by the automation. So the space, the speed of that process, privacy issues. If you look at the news, you will have a lot of these ones with the Gen AI recently and LLM. For example, companies undergoing digital transformation, AI transformation today often invest in an expansive new IT system and infrastructure without considering how employees will actually use that one. If new technology disrupts incentives, power structures, critical workflows, employee will resist. Okay, if we don't have any plan for that one, that comes at the cost of the failure of the IT system. Okay, let's move to the third part with the key socio-technical actors. Now we have talked about the history of the development ideas, and then now we are going to talk more about what it is. It's just one version of talking about socio-technical thinking. On the note of the actors, one popular assumption among practitioners is that technology adoption is universal. It's very related to it's being automatic by itself. However, it's slightly different. And that is if a system works in one place, say company A, it will work everywhere, company B, C, D, and D. However, there is a big if to this assumption. Technology is somehow shaped by its environment too. So take cashless payment, for example. Sweden is among the entirely digital. Most people won't carry cash these days. Probably we are getting to that state in Australia as well. But in other advanced economies, cash is still dominant. Why? And not because they lack technology, but because there is a historical and cultural basis for that resistance or low adoptions. Germans, for example, they trust cash more due to their concerns about financial privacy and government control. This is a perfect example how technology doesn't exist in a vacuum, in isolation. So the adoption depends on a social, cultural, institutional context. IT professionals must always consider these factors when designing, deploying, and implementing systems. Okay, I have already mentioned the role of the user a few times. Now let's examine it more carefully. Okay, when designing an IT system, we often think of the user as a single group. Okay, but in reality, different users experience technology in different ways. End user want technology that is easy to use and improves their work. Same system for the managers. Managers care more about the efficiency and cost. So for the IT team, IT inside your company support, they focus on the security, maintenance, and system performance. Ignoring these differences can lead to the failure. We have multiple actors looking at the same technology from different angles. We might use the Google Glass example here. Technically, it was a great product, okay, but potential users outside the tech community saw it as a really strange thing. So privacy concerns, social discomfort, and negative public perception. So at the time it was introduced, it couldn't be a very successful product. However, it was technically very good itself. That's an example of why technology itself is not an issue. We need to look at the user and the potential, and more important, the end user. A Apart from individual actors, users, there are other organizational and institutional actors that affects the working and relevance of the technical features developed by the IT experts, what you are going to do in future. In fact, how a system fits into the existing processes and institutions is super important too. We need to look at the processes that are routines and workflows people following their jobs. Institutions that are legal and regulatory frameworks and rules that will govern the IT adoptions. GDPR is an ideal example of institutional example. It's European Data Privacy Initiative. It's a law now itself. When it was introduced, companies worldwide, including here in Australia, they had to redesign their IT system. So to comply with it, this is straight new law. Even a system is technically perfect, they need to meet this legal framework. Okay, so you can see there are an actor like this law playing the role in the adoption of the technology. At a different level, IT development and adoption are shaped by the culture and government policies. The culture influences how technology is used. In some countries, for example, people embrace open office environment, okay, and then flexible digital tools, for example. In others, structure hierarchies makes digital transformation slower. Some studies suggest and indicate that countries like France or Japan, for example, have shown slower progress towards adapting to the remote and digital ways of working that includes the hybrid working as well. The other element is the government regulations can determine what IT systems can do and what can't do. For instance, the Australian government, federal government mandates that IT system should adhere to robust cybersecurity standards, primarily outlined by the Australian Signals Director, the ACD, through their Essential B framework. I'll put a link below if you really want to follow up. And also look at the China versus the American Silicon Valley. In China, strict internet regulations control access to the information. In Silicon Valley, so probably free market approach has led to the rapid information. You can see the government interest shapes how we use and how we develop the digital infrastructure and the digital products. So, as IT professional, you must pay attention to these contextual factors once designing a technology solution that's going to be global or national. Socio-technical system also considers the notion of the time, okay, the rule of the time, ruling of the time, I would say. Technology decisions has not been just about the present. They shape the future, sometimes very long future. What does it mean? Think of many organizations that still use a legacy IT systems. And these IT systems are outdated, but they are they are locked in, but difficult to replace. Why? Because decisions made in the past, years ago, will lock them into the long-term technical dependencies. So, and an example, there is a notion called 2025 cliff in Japan. It is predicted crisis where many IT professionals will retire, the old generation, and leaving the businesses and the younger generation struggling to maintain old computer systems, and they don't have the knowledge of that one. Without digital upgrades, this could hurt the economy a lot. There is a link to the study to the notion at here, and I've included at the end. IT professionals need to think beyond an immediate technical solution. So we need to look at the past, how we ended up here, and how our decisions of today are going to shape the future as well. IT use is beyond, that's another issue, is beyond the choices made by the IT department. Users shape how a system is actually used. When a system doesn't fit, people create workarounds. Okay, we are going back to the user notion, but here we are looking at the user in a more active sense. Okay, the user how are really active, not simply resisting or not using, but using in a slightly different way, which is called a number of things. There is a shadow IT notion here, there is a workaround concept here, very well established concepts in the field of information system. For example, NHS staff in the UK often use WhatsApp based on one story, and then if you Google it, you find a lot of stories here. I've included one here to share patient information because official sanctioned IT systems are slow and inefficient. Okay, this improves communication but raises privacy risks. For example, there is study in NHS, some places I've missed the part. So was warned for sharing patient data in authorized Google and WhatsApp group. This shows why employees should help design IT systems that fit their needs and secure the data. This proves a critical point. Users can be co-designers, but sometimes in ways that you don't like it as IT department, whether we acknowledge it or not. If we ignore user needs, they will find ways to pass on. Let's move to the next section. That I'm going again to fix one of the common misunderstanding with the socio-technical system. When people talk about socio-technical system, they say, "Oh, okay, you mean doing for good things for social goods?" Correct, but it's more than what's one. Socio-technical is more about the lens of how we see things. You may have already noticed that I have mentioned power, for example, power dynamics, political game when it comes to the IT. When people talk about IT, they often focus on efficiency for businesses or social goods, non-profits, voluntary organization, sometimes the government. How technology makes things faster, smarter, and more useful for the humanity in general. But socio-technical thinking focuses on forces actually. It focuses on a deeper issue and forces us to go in that place, to look at the very, very deep layer of how these incentives can be or can't be met. It's one thing which is very important is IT is not natural. It's really wrong to think IT simply is a tool. IT shifts power. Every decision about technology affects who benefits, who gets control, and who loses the autonomy. Okay, take workplace monitoring system for example. Companies say, "Oh, okay, it improves efficiency. With this technology we can let our employees to work remotely," but it also at the same time raises serious power and privacy concerns. Workers may feel pressured or even spied on, which can reduce the trust, job satisfaction, and even the performance paradoxically. Okay, so the real question isn't just is technology ethical or social good? That's great, but it's how the power is getting shifted, how it changed the theories by which we define the right and wrong as well. Many organizations rush into implement new technologies without thinking about the long-term consequences. Okay, but for technology to truly succeed, it must be effective, equitable, which it means try to be as inclusive as possible, avoiding biases and exclusions, and sustainable. It be adaptable for future challenges, future changes. One example is then AI-powered hiring tools, which is getting very popular these days. There is a study show that company loves them because they promise objective hiring decisions, so minimizing human biases. But if these tools are trained on a biased historical data, what's going to happen? They don't remove biases, they automate discrimination, they amplify biases, and there are studies that this is one of them, one example of them. There are multiple of these kind of studies. That's why socio-technical thinking is essential. An IT professional needs to ask what unintended consequences could this system create. Okay, let's move to the notion of power in more details. Okay, that's a very important one. When an IT project fails, people often blame technology. We've mentioned this before. This is an easy shortcut, but many failures happen because of the political struggles as we've mentioned. IT can centralize or decentralize control. Some groups benefits, other feels in danger. Remember the golden triangle case. A company introduces financial IT systems to centralize decision making, to make it efficient, to make it available for everybody. But division managers resisted that one because it reduced the local control and fears of the autonomy as well. Instead of streamlining the operation, the system created conflicts. This tells us something important to it. IT is beyond a bunch of technical functionalities we put together. It's technical functionalities, power structures, so perceptions, autonomies, benefits, gains, loses. We put all them together again as a designer. If you are really interested in the notion of the power, I highly recommend this book from a colleague of mine who is it's a giant in this field of the power in the organizations. A great scholar. So if the technology isn't just functional, it's a tool, the way a company uses and markets technology will shape how it's perceived. And one good example we might consider here to see how it has consequences for marketing, for branding your company as well. NVIDIA, so it started as a graphics card company, but in recent years, you know that one as a AI chips company. It's rebranded itself. The company leveraged AI-driven business analytics and marketing narratives to reposition itself. Okay, and what was the result? Investors responded positively because this rebranding has been done through a socio-technical lens, considering what's hype in the society, what's going to happen next. So what are the political forces, what are our social demands, what are the economic aspects, and then all together create a very strong position. This case again shows the IT isn't just a tool, it could be a symbol of the progress and power. Organizations strategically use IT to build legitimacy, attractive investment, and position themselves. There are dozens of examples in my mind, which I don't have the time to share with you, that the companies purchased an IT system or they have done an IT project simply in a symbolic way, okay, simply to be able to go somewhere in a conference or meeting and showing the client, showing the investor, we have this one. Okay, and again, this is something that you can capture through the socio-technical lens. Let's get back to the users and what role they play. You can see I'm going and back between different concepts to gradually take off from these notions. When a new system, IT system, digital system introduced, different user given their role and responsibilities, it depends on where they are based, they see it differently. Again, to use an example for this one is a MasterCard's AI-driven marketing. The same AI system had completely different meanings for different groups. Okay, for manager it was just a tool for more efficient, better decision making. For investor it's a proof that the MasterCard was a leader in digital transformation. And employment were divided. Some like it, the efficiency aspect, some didn't really like the job automation aspect. Again, you can capture the flavor of the socio-technicality through this example as well. Now we are going to move to the last part, which is, okay, so what? And then how we can take an action based on this understanding. Let's focus on what this new way of thinking means for the professionals. Okay, to start, let's imagine an IT professionals as an architect rather than a builders. Okay, there is a great part of design, not simply technical design, social design as well. A builder follows instructions and construct what is in front of them, but an architect, they design with the future in mind. They think about how people will move around a building, how different materials interact, and how structure will evolve and be maintained over the time. Similar in IT, your job isn't just to write code or deploy software. It shapes a system that people will use and depend. And in doing that one, you need a set of skills, technical skills, social understanding, and strategic thinking. Okay, the biggest IT failures fail because one component is missing. So yes, technical knowledge is a must, but social understanding, how people actually use it, for example, and strategic thinking, it's how it's going to affect the organization over the time. Every time you work in an IT system, you are making choices that shapes people's lives. Think of an IT professional like a bridge builder. If you out concerns, the bridge might still stand for a while and then under stress collapse. So the same is true for the IT. If we design an AI-powered hiring system without thinking about biases, you remember the case, we might unintentionally reinforce discrimination. Okay, this is why IT professionals can say, I just build a system, it's not my problem. Whether we like or not, we are responsible for how our system shapes the world. As a part of that one, you need to see the big picture. Okay, you need to ask. Many IT professionals start with a tech first mindset. That is wrong. That's a problem. We need to build a solution, and we need to build a technical solution for a problem. That is incomplete. Socio-technical says, before you build anything, understand the system and its parts and the context within which it exists. How will different users interact with it? What might go wrong that haven't anticipated? Will it work as organization and society evolve? You remember the notion of the time. So there are many examples in this space that you can capitalize and shows how it's important to consider these elements all together. IT professionals today are navigators. This is the third metaphor I'm going to use The first one is architect, and the second one is bridge builder, and the third one is navigators. You're string technology through a complex ocean of the social, ethical, business challenges. If you only focus on coding, programming, it's just like you are just going for a trip without any compass. Okay, you need a compass to go through. You will build system that works in short, in isolated cases, but crashes in a bigger picture. For these ones, we might rephrase the skills you need: critical thinking, interdisciplinary knowledge, and communication skills. Okay, there are different kinds of the skills that tick or support the navigatory role of the IT professionals. Okay, let's summarize. One of the biggest mistakes that we make in IT is believing that technology is neutral, but in reality, every IT system is shaped by social, economic, and political forces. And in turn, it shapes those forces as well. There are many examples that you can see, you can learn from them, that they have used IT as a political tool, as a symbolic tool, as a functional tool, and some other very mistake use of the IT due to non-technical issues. The key here is IT isn't just there as a tool. It performs stuff. It has consequences. Sorry, I'm just wondering. It shifts, recreates perceptions, power, and influence. Okay. Yeah, and then we have spoken about the NVIDIA example in a different way. Many people enter the IT thinking. They simply just want to write the code and configure the system. But the reality is, an IT professional, I'm so sorry guys, you are also designing human experiences. You have a bigger responsibility. A system doesn't succeed because just it works technically. It succeeds because it fits with the people's lives. It fits within the people current understanding of the world. Let's take again, remember the AI powered hiring example, the tool. On a paper, okay, it's the perfect solution. AI remove human biases, but it's wrong. In reality, the system amplifies some of the decisions, some system actually, and they often inherent and reinforce the human biases. If company historically hired one class of the people, let's say mostly men for the leadership roles, the AI will learn, and then if we use the same AI, we may replicate the gender discrimination. Okay, and that's the reason you need to be aware of these ideas in your career as well. Before we finish off, I want to leave you with a challenge. Okay, imagine an AI system that predicts job successes with 99% accuracy. Okay, sounds great, sounds a perfect tool for many organizations. But you need to ask yourself to practice your socio-technical thinking. Who gets to define the success in a job? What happens to that 1% who are wrongly excluded? Okay, who is responsible for that decision? AI? The developer, the system, the developer, or the company? This is why IT is not just a technical, it's socio-technical, and that's why you as IT professional need to think beyond the code and systems. Thanks very much. This is a number of most important references I have used. I hope you have enjoyed this talk. I've been very quick, so I've been trying to simplify, streamline as much as possible, sometimes at the cost of just working around a little bit with the concepts. Thanks very much. See you later.